Okay. So for this problem, it's two triangles inside of one, like we talked about in class. So you have the sand dunes. Cole's approximating the angle of elevation to the top of the sand dune is 20 degrees. So let's pretend that Cole is right here. Okay, I'm just going to start from scratch. Let's pretend Cole is right here. And it says the angle of elevation to the top of a sand dune. So you know that the sand dune is up here, right? So our angle of elevation, you do a straightaway, then you swing up, and then we'll do some kind of line. We're going to label this as 20 degrees. Now it says, so we know something like that, right? We can create a right triangle. Now right now that's all that we know. We don't know how tall the sand dune is. We don't know the base length. But then the next part says, after walking 800 feet closer, so 800 feet closer to the sand dune, if the sand dune's right here from the base, if it's on the ground, as he walks 800 feet closer, doesn't matter how long you make this, but you know it's not all the way to the end, right? That's 800 feet. So as he walks 800 feet closer, we'll call this little segment 800. He now has an angle of elevation. So now if this is him, right, if he's standing now over here, from here, his angle of elevation changes and is increased by 15. So if it was 20 and now it's increased, you're adding 15, it's now going to be 35 degrees. So as he's closer and he does a straightaway and his eyes swing up to this point, that's 35. And it should make sense because when you're farther away from something, your head doesn't swing up as much to look at it. Like if you're far away from a tree and you're trying to see the top of the tree, and you're really far away, you don't have to usually tilt your head as much as if you're closer, right? If you're standing right under a tree, you have to swing your head up really high. So that's why when you're closer to that object, your angle of elevation should be larger. So notice it becomes two triangles in one. Now there's a bunch of things we don't know right now, right? We don't know this. We don't know this little segment, and we don't know this segment. So let's see how we want to fill them out. It says approximate how tall the dune is. So when we're trying to approximate how tall the dune is, we're going to want to label this side as some variable, right? We can label it as y, or it doesn't matter if you label it as something else, because that's what we're trying to find, right? We want to know what y is, so we'll label it as some variable. Now we need to write something in here to represent that section, right? You can't leave it blank and the whole bottom isn't 800. So that's why we can say this little section is unknown. We know he walked 800 feet closer, but we don't know how much farther to the base of the sand dune he was, right? He could have been like 200 feet away, or it still could have been 500 feet away. We don't know that information. So let's continue with the problem. So now you notice how we set up this triangle inside a triangle down here. So I'm going to erase what I just did. And I'm going to draw those two triangles separately. So if you see out here, you guys did this in geometry, right? Out here, if you just look at that green triangle and you don't look at that, right? And you just see this big green triangle. Then over here, I'll draw the green triangle as 20 degrees. This is y. Now be careful. The bottom of the green triangle, that bottom length, is 800, and so we'll put a plus x. 800 plus x. Now I'm going to create another triangle. So I'm going to erase this big picture right here. And I'll do it in another color. Let's use blue. So right in here, I see another triangle. Triangle angle 35 degrees. Its base is x. And then over here we have y. So sometimes for me it helps to set them up separately. Now, if we're trying to find out how tall the sand dune is, the y, we don't have enough information from either the green or the blue to move forward and figure out what y is, because you have two unknowns. So that's when we're going to need to create two equations, okay? So for the first equation, I'm going to create an equation for the green triangle. If I want this, and I have this in reference to the 20-degree angle, I want the opposite, and I have some information for the adjacent. So out of SOHCAHTOA, I'm going to go with tangent because I want the O and I have some information for A. I don't want to go with sine or cosine or I'll get stuck. So the tangent of the angle, tan of theta, is its opposite over its hypotenuse if I look at the green triangle. Now I'm going to look at the blue triangle, so let's box this up. This has to do with the green picture, the green triangle. If we look at the blue triangle, same thing. I want the opposite of angle 35. I want the opposite, and I have something for adjacent. And again, what has O and A is tangent. So I'm going to create an equation. Tan of 35 equals y over x. It's opposite over adjacent for the blue. So the blue box is an equation for the blue triangle, and the green is for the green triangle. When you have two unknowns, like we have here, right? We have two unknown variables. When you have two unknown variables, we're going to want to use substitution. So for both of them, I'm going to isolate y for one of them. You know from algebra 1, if you had y equals 2x minus 1 and y equals 3x minus 7, you could take all of this and substitute it for the other y. You could solve for x and then go back and solve for y, right? So we're going to do that same stuff here. So just decide which one you want to isolate y for. We picked the bottom one just because the denominator wasn't as messy. You can isolate either the top y or the bottom y. So to isolate y, we're going to multiply both sides by x, right? So then y equals the tangent 35 times x. So now we can take all of this stuff and plug it into the other equation in the y slot, right? Substitution. So that's what we did here. If this red was the y spot, we inserted this y expression. So then from there, we're down to one equation where we only see one variable. As long as you have one variable, one unknown, you can solve. So let's try to solve for x. So we first are going to multiply both sides by the denominator. So let's multiply the left and the right. Left and the right by 800 plus x. Because it's more than one term, we're going to use parentheses. It's an expression. We're going to cancel denominator in that. So on the right, we're left with x tan 35. On the left, we have the quantity 800 plus x times tan of 20. From there, you're going to distribute combined like terms, right? Tan of 20, think of it, it's a number, right? So think of this as an easier algebra problem where you had like 800 plus x times 4 equals x times tan of 35 is still some value, right? So pretend it was 3x or x times that number. Then you distribute, you get all terms on one side, and you solve for x. So think about it like that. Let me erase this. Okay, so let's continue. So then what we're going to do is we distribute, and then we're going to combine like terms, right? So 800 times tan of 20 is 800 times tan of 20. This is a numerical value, right, when you plug it in your calculator, because tan 20 is a number times 800 is a number, but we'll do that later. And then we're going to distribute tan 20 times x, so we get plus x tan 20. And then on the right-hand side, we have x tan 35. And now, after we distributed in this last step, we're going to get like terms on one side. So we want to move all of our x terms on one side. So that's why we want to move this expression over here. So we subtracted x tan 20 degrees from both sides. That's why it disappeared here. So we had, on the right, we already had x tan 35, and then we subtracted that x tan 20. On the left, we had 800 tan 20. Now for the next part, you can do this a few ways. On the right, we can factor out the x, right? And if we factor out the x, we would have x tan of 35 degrees minus the tangent of 20 degrees. And then we could divide both sides by that quantity, tan 35 minus tan 20, and that's what you see here. So when you divided both sides by tan 35 minus tan 20, you had the 800 tan 20 divided by that expression. And so when you simplify over here, 800 times tan 20 divided by the quantity tan 35 minus tan 20, you get x equals 865.98 feet. So now we know over here that x is 865.98 feet. Now that's not the answer, right? They asked us for the height. That's what they wanted. That was just the distance remaining as we got closer. So in order to find y, just like in Algebra 1, you can go back to either equation and decide which one you want to plug that information in for x to solve for y. So if you go to the second equation, it's a little bit easier, right? If we went to the second equation, this one, we could do tan of 35 degrees. If it equaled y over x, and we know x now, we could do tan of 35 is equal to y over, we just found out that x was 865.98, and then we're going to isolate y by multiplying both sides by 865.98. So tan of 35 times 865.98 is equal to 606.37 feet. So that is our answer. Please fill this out and submit this.